Hello everyone, and welcome back to the ccubed channel. This is another tier 1 video, so we're going to be focusing on the Edexcel GCSE Maths Foundation tier. So again, this is for students that are in that group, and also for people who want to start from absolute basics. So today is going to be continuing on from the last session, which is talking about simplifying expressions. And today we're going to be talking about indices laws. So we're going to be going over 6 of them. 3 we're going to go into detail, and then the other 3 just going to be left over at the end, which are usually quite easy to, understand. So we're going to quickly go ahead and recap what we've done in the last session regarding multiplying variables. So remember that we said how we got x squared. So to do that, remember it was x times x, and we said x times x is basically x squared. And the example we used for that was, for example, 3. So 3 times 3 is 9, and we also know that 3 squared is also 9, so the equality holds there. And we did a similar case for x cubed, where x cubed is x times x times x. So we're going to quickly go ahead and continue on from this. We're going to branch a bit further, and we have a general case of this. And so if you have an infinite list of x's, so x times, this thing here just means it goes on until it gets to the final x. That means we can say that there are an n amount of x's, right? So this is where we get x to the power of n. Now we said earlier that we can actually, we can get these cases from the general case. So if we make n 2, then we just have 2 x's, so x times x, and that's what we have here. X times x equals x squared. If we make n equal to 3, they would have 3 x's, so x times x is equal to x cubed, and so on. So, x to the power of n, if n is 4, then you have 4 of them, 5 would be 5 of them, how it goes on. So that's what we have for that. And now we can actually combine these further, so we have new ways of simplifying expressions. So we're going to go into the indices laws now. So the first one is for multiplication. So let's consider 2 different indices here. So of x to the power of m and x to the power of n. Remember we said that these could be any number, but in this case they have to, they could be different or they could be the same. Actually, it doesn't really matter. But just make sure they're 2 distinct, different, variables. So if we want to multiply these together, then you would use the multiplication rule, which says that x to the power of m times x to the power of n is equal to x to the power of m plus n. So all you do in this case is you keep x the same, and you just add the powers together, and that's what you get here. That's the multiplication rule for the indices, I should say. So we've got 2 examples here. If we have x to the power of 5 times x to the power of 7, then we just quite simply add them up. And we get 12, x to the power of 12. Okay, so it's just 7 plus 5. We get 12, x to the power of 12 done. For the second situation, we have x cubed times x to the power of minus 1. Again, you just add them together. And in this case, actually, because remember there's a minus 1 here, so it'd be doing 3 plus minus 1. And if you know from the rules of adding is adding negative numbers, that is equivalent to just 3 minus 1. So you just get x squared. Alright, so that is all we have for the indices laws for multiplication. So let's go on to the next one. What about division? So we have, let's consider the same 2 variables again, x to the power of m, x to the power of n. If we want to divide them this time instead of multiplying, they would have x to the power of n, m, I should say, divided by x to the power of n this time, and that is equal to x to the power of m minus n. So the difference here is when you multiply, you add the indices together, and when you divide, you subtract the indices from each other. Always the top one minus the bottom one, so m minus n. Always keep that in mind. So we have a quick example here, x to the power of 7 divided by x to the power of 5. And that is quite simply x to the power, it's quite simply 7 minus 5 in the indices, so you just have x squared, and that's what you get from that. Okay, cool. So that's multiplication and division sorted. So let's go into the index rule now. If you're having indices on the index, what would happen then? So what do I mean by that? So let's consider the two let's consider the two variables again, x to the power of m and x to the power of n. The index rule now is if we have x to the power of n, and then that is to the power of n. So, quick example there, we could say in, a simpler version, say x squared, and then cubed. So the x squared itself is cubed. So that's what we said here, x to the m is all to the power of n. And then if you want to simplify that out, you quite simply multiply m and n together. You multiply the indices in this case. And so you just have x to the power of m and n. And the reason why that works is simply because, let's just quickly do this. So remember that anything to the power of something means it is multiplied by itself that many times. So in this case, you have x squared multiplied by itself 3 times. So you'd have x squared times x squared. Ooh, that's a bad 2, but it is in fact a 2. Oh, I made it worse. Alright, let's just quickly kind of salvage that. Yeah, we can. Okay, and then multiply by x squared. So we have 3x squareds here. And then, using the addition law, if you remember, you multiplication law I should say, you add the indices together. So, we are adding these together, and so you get x to the power of 6. And if you look at that, that is in fact 2 times 3, which is 6. So that's why this works. So this actually is kind of a branch off from the multiplication rule. Okay, so we got some examples here. So again, we've already done this one actually, so that's not really, needed. So let's do the second one. So we have x to the power of minus 1 to the power of 2. So x to the minus 1 squared. So in this case, we just multiply the 2 together. And minus 1 times 2 is minus 2. So, there we go. X to the power of minus 2. Done. In terms of more rules, there are in fact 3 more rules. We're going to quickly go over these other index laws. So we have 3 of them here, the other 3. So we have the surd rule. So the surd is basically this thing here. This is, you would typically see this for square root, but it can actually be for higher powers, as we'll see when I get into more of the surds in the future. So right now it's just kind of a basic introduction. Just know that these exist. But in the future I'm going to make a whole new video on surds in general, how to simplify them, how to multiply them, etc. But for now, we're going to focus on the surd rule. So x to the power of m over n is equal to the nth root of x to the power of m. So practical example of that we will see in the next slide, but just know this is what the surd rule is. So this can be rewritten as a fractional form, and typically this is preferred when you're dealing with higher end stuff, as we'll see when we get into calculus for A-level stuff. But right now, don't need to worry much about it, just know that this is a equality. Then we have the power of 0 rule, which says that anything to the power of 0 is always equal to 1. Now I put here that x cannot be equal to 0. That is because the value of 0 to the power of 0 is kind of ambiguous. There's a lot of mixed, there's a lot of mixed results from that. A lot of people say that you can let it be equal to 1. So in algebra, you could say that 0 to the power of 0 is equal to 1. But in other cases, it can be left undefined, meaning we don't know. So in this case, I just left it as this to say don't make it equal to 0, because we just simply, there's kind of not really an agreement here. So generally, anything to the power of 0 is equal to 1 except for 0 itself. That's what we could say. And then the last one is a reciprocal rule. So x to the power of minus m is equal to 1 over x to the power of m. This is a very useful rule actually that will again be used later on in calculus and other areas, because this can really save yourself quite a lot of hell, honestly. So this is very nice to have in mind. And the power always has to be negative for this to happen. So it always needs to be a negative power. Otherwise, if it's a positive power, then you just leave it as that. So let's do some quick examples here. Again, we don't need the 0 power rule because that's kind of obvious. You don't really need an example in that. So, and let's simplify this. So x to the power of a half. So this, remember what we said earlier, m is 1, n is 2. So m will go there, 2 will go there. So let's do it. Let's do this. So we got x to the power of 1, and we have a 2 on the out. Ooh, that's a bad 2. 2 on the outside. So thing to note, x to the power of 1 is just x, because it's just x on its own. So we can leave x in. And typically for powers of 2, you never actually write it. So you could just leave it as square root of x. And that is what x to the power of half is. So x to the power of half is square root x. And again, this is a very, very useful equality that, again, this will be used a lot in the future. But for now, this is what we know is true. And then, for the last situation, x to the power of minus 3. Remember we said anything with negative powers follows the reciprocal rule, so it's 1 over x to the power of m. So in this case, m is equal to 3. So it's just going to be 1 over x to the power of 3. So at 1 over x cubed. And that is it. That's all we have on the indices laws. So that's all I really had to say on the indices laws. Thank you guys so much for watching. In the next video, we're going to be taking a step further. We're going to be looking... The next step now will be looking into expanding and factorizing expressions, which uses concepts from this and the last session. So we're kind of just building up towards being able to eventually solve our first equation. So that's kind of the goal right now. So, thank you guys so much for watching, and I'll see you all in the next video.